Hello everyone, this is N. Kavita working as Assistant Professor in Department of Electronics and Instrumentation Engineering, Hindustan College of Engineering and Technology, Coimbatore. Today we are going to see a topic on potentiometric transducer. A transducer is a device which is used to convert a non-electrical quantity into an electrical quantity. Out of which today we are going to see a potentiometric transducer. So this potentiometric transducer is also called a resistive transducer because this transducer works on the principle of change in resistance. So these transducers are generally used for calculating the physical quantities like pressure, vibration, temperature, force and displacement into electrical quantity. So out of which this transducers whose resistance varies is known as a resistive transducer. So potentiometric transducer is a kind of a resistive transducer because this transducer works on the principle of change in resistance. We are going to see what are all the working principles of the potentiometer. The major working principle is the conversion of physical input, which means in potentiometer, the displacement which I provide to the shaft is going to be my physical quantity of input. So this displacement is being converted into the electrical quantity, or I can say it as a position of my shaft, because whenever I provide displacement to the shaft, what happens actually is the position get varies. So the input may be a displacement or the position. So how does it change into electrical quantity is it doesn't directly converts the displacement into the electrical quantity. Intermediate, there is a process called resistance variations. So we know the basic logic that the resistance varies depending upon the length, area and resistivity of the materials. So in potentiometer, we are going to see there are two different types of potentiometer, namely linear potentiometer and rotational potentiometer. Instead, my potentiometer is of different categories like linear potentiometer, rotational potentiometer, trimmer potentiometer and digital potentiometer. Out of all the four potentiometers, we are going to concentrate with two potentiometers. One is the linear potentiometer, the other one is the rotational potentiometer. Let us look into the construction of the linear potentiometer. This linear potentiometer will be having a mandrel. Around the mandrel, the resistive wires are being wounded. Across the ends of the mandrel, we connect an voltage source and that is considered to be the input voltage source. So across this mandrel, we have a wiper. This is called the shaft. With the help of this shaft, I can provide my input displacement. So whenever the shaft is getting moved, say for example, if the shaft is placed at the center position, I can able to obtain the output voltage from this position to the end of my potentiometric arrangement. So that voltage is termed as the output voltage E0. So we will now look into the other type of potentiometer. The construction is exactly similar. The only way is the displacement is made in a linear way. Here, the displacement can be moved in rotational fashion with the help of the wiper, and I call them as resistive track. So the construction is more or less similar with the only difference there will be a linear arrangement of resistance in case of linear potentiometer, whereas in case of rotational potentiometer, the resistance is given in terms of a track. Now let us look into the working principle of my potentiometer. So you consider this as a resistance where I am moving and you assume this line to be the displacement or the shaft where I move. Say if in case the total length of the resistance can be given by the xt and the total input voltage can be given as EI, which is my input voltage. You assume this line to be the position of my shaft. Say for example, if the position is at this position, I can able to measure the length and that is called the input displacement Xi. So we are about to check this input displacement is how converted into the output voltage E0. We will look in detail. Say for example, whenever the displacement is made, the input displacement is called Xi and the voltage across the displacement is called E0. So I can make into the conclusion that E0 can be obtained by the input displacement by total displacement with the input voltage. So the resistance can be easily calculated with the help of this formula. So here the major input which I provide is the displacement of the shaft. Based on the displacement of the shaft, the output voltage is calculated. We will now look into the characteristics and performance. The sensitivity and resolution of the potentiometer is very high when it is compared to the other kinds of potentiometers. The linearity and hysteresis is also very evident. The linearity of the potentiometer is an ability of its output which is directly proportional to the input. which means whenever I provide the displacement, I get the graph which is very linear to that of the output voltage. So the linearity of the potentiometer is very directly proportional, and the temperature and pressure effects will definitely affect my potentiometric transducer's working principle. So these are the major characteristics and performance of potentiometer. We will now look into the advantage and applications. We have got various advantages of potentiometer. It has a precise measurement. It is very simple and reliable. So potentiometer can be used to vary the resistance in various fields. Its major application plays a vital role in automotive industry and industrial automation. We will now look into the practical application, like how my potentiometer works. Hello, this is N. Kavita, working as Assistant Professor in Department of Electronics and Instrumentation Engineering. Today we are going to see a practical on how the potentiometer works. A potentiometer is a device which is also called as a pot. In turn, the potentiometer is called a resistive transducer. We are going to see two types of potentiometer today practically. One is called translational potentiometer. The other name is linear potentiometer. The other one is rotational potentiometer, or it is called a rotary potentiometer. So this potentiometer will works on the principle of change in resistance, and hence it is called a resistive potentiometer. We will just look on to the practical application of how my potentiometer converts my resistance into the voltage. So this is the basic construction part of my potentiometer. What will be there inside this is we have got a resistance, and this resistance can be varied with the help of the shaft. This movable part is called as the shaft of the potentiometer. So across this shaft you can find out a linear scale arrangements in parallel. So whenever I move this shaft, according to this shaft displacement, I can able to observe my displacement readings at the top end. So what happens here is whenever the displacement is given with the help of this shaft, inside this specific area, the resistance is getting varied. The change in resistance is being converted into the output voltage. Here, it is to be observed that the potentiometer doesn't convert directly the resistance into the voltage. The input providing us the displacement, which is provided with the help of the shaft. This shaft will change the resistance. In turn, the resistance is converted into the output voltage. The output voltage can be measured with the help of the multimeter, and it is to be observed that the multimeter should be in the DC condition. And this potentiometer is in turn called a passive transducer, which means for this operation I have to provide an external power source to the potentiometer. Now let us look into the working of potentiometer. Initially, I am not moving my shaft, which means the displacement is exactly 0, and because of few external disturbances, the output voltage which I observe is 0.0. Here, I am going to move this shaft, and the linear arrangements can be noted with the help of this knob. When it is moved to 1 volt, you can observe what will be the output voltage. When my shaft is nearing 1 voltage, you can observe my output voltage. The output voltage is around 1.142. When I move this shaft to the position of 2, which means still I am varying my resistance. When the resistance is getting over to 2, you can observe here the shaft position is given to the position of 2. You can observe that the output voltage is around 1.96, which is approximately equal to 2. When you observe this case in case of 3 voltage, when it is provided to 3 voltage, you can observe the output voltage which is around 2.82. So what happens here actually is, I am just moving my shaft, which means the resistance is varied, the position of the resistance is getting varied, and we know that the output voltage can be calculated with the help of the input voltage or the displacement which I provide to the potentiometer. This is in case of linear potentiometer. When you jot down, when this displacement is given to the maximum, as of this trainer kit, the maximum voltage is around 5. So when it is moving to around 5, the voltage which I obtained is around 4.9. So this clearly indicates, and when you jot down the model graph for this, you can observe that there will be the displacements when you observe, the displacement is provided in case of centimeter, the output voltage is obtained in terms of volt. You can observe that according to the input displacements, the voltage increases linearly, and when you plot a graph against your displacement and output voltage, it is very evident that the graph increases linearly. So the concept is very clear. Here the displacement is converted into change in resistance, which in turn converted into the output voltage. Next, we are about to look into the rotational potentiometer. Here the displacement will be provided in terms of degree. This is the shaft over here. So in linear case, we find the shaft which is in the metallic position. Here we can able to rotate the shaft, and that is why it is called a rotational potentiometer. You can observe here altogether there will be 360 degrees which is available in the rotational potentiometer. Whenever I move the shaft, according to the shaft, the output voltage can be varied. So, being a trainer kit, I am just putting this multimeter pin towards my rotational potentiometer, and I am going to observe what is my output voltage. So, the concept is very similar in case of linear potentiometer, being the only difference is the displacement is provided in terms of a rotational way. So, when you observe here, this is in 0 degree, and when you observe my output voltage, it is in 0. Later, when I move over this degree in 20 degree, you can observe that the voltage is in 0.3 volt. Similarly, when I put this to the maximum in case of 120, you can observe my voltage, it is in 1.75. So what happens here actually is, again we are going to jot down the arrangements which is very similar to the linear arrangement. The only difference is here the displacement is in terms of degree and the output voltage. When you observe the reading, it is very evident that when the displacement is increased, eventually the graph is also increased linearly. So the only thing which you have to note down with this potentiometer experiment is that whether it may be a linear potentiometer or a rotational potentiometer, the displacement is being converted as a change in resistance. The change in resistance is being converted into the output voltage. So this is the very basic concept, and this potentiometer is called a linear potentiometer or a resistive potentiometer because of such exhibition of this characteristics. Hope this video helps you to understand the practical application of potentiometer and how does the potentiometer works and what are all the types of potentiometer. Thank you for watching the video.